Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Data Waves. Today we got an exciting topic in unified access for your data mesh, self-service data with Dremio semantic layer. Bottom line is people want data mesh, and it's not just because it's a fancy buzzword, but it's because uh, data is scaling to grand scale and having sort of like centralizing all aspects of providing that data just becomes really difficult to do at scale. So you need an architecture that kind of allows you to break that up. And we're going to talk more about that as we go through today's presentation. But before we do that, you know the deal. I want to talk about Dremiotestdrive. Bottom line is you're going to see that after today that Dremio is a great tool for implementing those kind of architectures that are going to make it easier to manage that data at scale in an architecture like data mesh. And if you want to kind of see how the data lakehouse can play a role in that and see this data lakehouse platform in action, head over to dremio.com, go to hit that test drive button and try it out. But also, okay, many of us over here at Dremio, we are writing Apache Iceberg, the definitive guide, a new book from O'Reilly that's going to be coming out early next year. So basically, get your hands on the book. You can get your hands on an early copy of the book by scanning that QR code right there. And we have many other upcoming episodes of Gnarly Datawaves in the coming weeks. Okay, so next week we're going to have easily migrate Hadoop workloads to AWS with Dremio. So learn more about that Hadoop modernization, that Hadoop migration story. And then the week after that, learn how Memorial Sloan Kettering accelerates cancer research with Dremio's data lakehouse. So learn basically how lives are being saved when you have better use and better architecture of your data, and you can better wrangle that data. But Dremio will also be present in organizing these events with AWS, these AWS Dev Days, these AWS Summits in Toronto, Chicago, New York. So if you happen to be in any of these locations on any of these dates, make sure to check out the event. And also, Dremio will be present at all these conferences around the world, whether it's Big Data AI Paris, Big Data London, Coalesce by DBT, Data Festival in Munich, Big Data and AI World. Where if you're at any of these events, make sure to check out the Dremio table, pick up some swag. There's gonna be some cool stuff. But with no further ado, let's get on to our main or featured attraction. Okay, unified access for your data mesh, self-service data with Dremio semantic layer, and your presenter this week is moi. Okay, so I will be your chaperone through this journey. But bottom line is to understand, you know, the journey. You have to kind of understand, like, one, what we would like, the world we want, like, what are we working towards, and where we are at. Okay, so first let's talk about a data utopia. Like, if everything was perfect, what would that look like? Our data would be consistent. Okay, I basically would be able to update our data. I'd be able to access my data from different places, and it's always the same data. The data is fresh. It always reflects now. It's not, basically, ideally, there wouldn't be any latency. It wouldn't be data from minutes ago, hours ago, weeks ago. It'd be the data of now. The data is correct. Okay, it's not only fresh and consistent, but it's correct, because who wants consistent wrong data, right? So we want to make sure the data is correct and consistent. No matter where I go, I'm going to see the same data, and that data is correct and fresh. It is discoverable. Okay, it's great to have up-to-date, fresh, consistent data, but if I don't know where to find it, then, well, that doesn't really help me either. Okay. Now, the data is accessible by the right people. Okay. At the end of the day, we got regulations to deal with. Okay. We have internal controls, promises, SLAs with our customers as far as their privacy goes. So we need to make sure that the data is only accessed by the right people in the right context. And the data that is accessible by them meets all these other criteria of consistency, freshness, correctness, and discoverability. So ideal world, all these things would be true. Okay. I'd be able to just sit there and do a quick Boolean check on each of these and be like, true, 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 true. But in all reality, oftentimes the data is inconsistent because there's just so many copies being made. Okay, when you think about, like, hey, you take a copy from your transactional databases, you move to your data lake, then you move a portion of that over to your data warehouse, and then you make copies of that for different data marts, and then some of that gets extracted for data extracts, speed up BI. There's just so many different data copies of the same data set that they become inconsistent. The data is stale. Okay, the problem is there's just so much data, and since the provision of that data is all done by a centralized team, okay, doing all the data, there's just too much for them to, there's just too much of a backlog, too much of a workload, that it's hard to kind of keep up and meet those SLAs. Okay. The data is, oftentimes isn't correct. Okay, what happened is that it's hard to do a lot of those quality checks and monitor and observe that data in process because you're so busy trying to meet those SLAs. Okay, and having in those and basically all that engineering requires you to make so many copies and create the pipelines to make all those copies. Okay, oftentimes there's going to be mistakes along the way, and then you're getting, you're creating insights based on incorrect, stale, inconsistent data. Okay, the data is coming from so many different places and going to so many different places. What data sets exist, accessible by who and where, becomes pretty difficult. And oftentimes, it's hard to manage permissions in 50 different places. Okay, so then what happens is that sometimes the data is accessible by the wrong people or not accessible by the right people. Okay, and where those levers get pulled and how they get pulled can sometimes be very unclear. Okay, so the idea is we're trying to get to the utopia from the reality. And again, a lot of these things aren't tough to manage at smaller scales. Okay, oftentimes at smaller scales, you can use a much simpler set of tools and a smaller team, and you can manage all these things pretty well. Okay, the problem is what happens when you get to like that big data scale, that multi terabyte or multi petabyte scale. Okay, where it's just so much data being generated and it has to be in so many different places in so many different ways. Okay, that you start having all these problems. Okay, and this is where like data mesh comes in. Okay, the data mesh is going to take that problem where basically, we've gotten to the scale where these centralized solutions, the centralized approach just doesn't scale anymore. And what we do is we're going to break up and basically lean on what's called the division of labor and say, hey, we're going to break this up and say, hey, different teams are responsible for different chunks of the data. Because again, data is manageable, at the right scale. It's when it's just one team trying to take care of too much data. So how about we have a lot of small teams taking care of a smaller amount of data that they can do and manage and monitor better. Okay, so that way those teams are each individually responsible for meeting SLAs on their subset of the data. Okay, so basically instead of having one team being behind on one data affecting all the SLAs on every other set of data. Okay, so the idea is we're breaking it up because the point is there's just too much data for one team to handle. So we're going to break it up into smaller teams working on smaller amounts of data. Okay, so that way we distribute, we diversify that risk of of inconsistency, of staleness, and all these things. Okay, but the thing is that when you create the data in a more distributed way, there's that whole issue of discoverability. Again, yes, great, we have all these smaller teams that can maybe manage their scale a lot better, but the idea is that the end users still need to have access to maybe multiple sets of these data products, and they need a way to discover that data. And this is where like a semantic layer comes into place. Okay, Dremio semantic layer really makes it easier to one basically distribute your data across different what's called spaces. Okay, so that way you have logical layers to represent different data products. So here's my, product data product, my marketing data product, my accounting data product. Okay, but allows you to kind of really granularly control the access to all of those from one place. So and it doesn't matter where the data lives. The data could live in many different sources. So you have many different sources of data depending on which team is using what for what data, but it can all be sort of filtered through and sort of centrally governed and computationally governed from Dremio's semantic layer. So that way each team just focuses on getting their data together and they all meet up in this one place to kind of make that data available and discoverable. Okay, so it's a layer for organizing because again, you can organize that data into different spaces. It's very clear. Okay, this is the marketing space, this is the product space, this is the finance space, etc. You can provide documentation. There's going to be a wiki there, so that way you can provide documentation saying, hey, what data set is this? What things should I know about this data set? Okay, the kind of details that oftentimes, hey, you have access to a data set, but you know nothing about it. Okay, and governing, again, setting up all those access rules can be all done from this one last space, along with visibility into your data's lineage. Okay, and again, you're reducing the amount of copies because it's all based on generating views from data sets and having a lineage of data logical views instead of physical copies over and over again. Okay, and that's going to allow the data to be more consistent because when those original data sets change, all the views based on them change. Okay, so again, one central place for all end users to discover data, even though all your data is produced or organized and created in a decentralized manner. Okay, one central place to manage the access to all of that data. So again, all the things that need to be centralized are centralized, and all the things that need to be decentralized can be decentralized. That's the beauty of this. And then again, you have documentation and lineage so that way you can track, how did these views get generated based on what data sets, who did them, and also you can write documentation so people can know what they need to know about different data sets. So to kind of give you like a different like bird's eye view, bottom line is with Dremio, it doesn't matter where the data comes from. It can be coming from data lakes, whether it's an on-prem, like a Hadoop-based data lake, or a cloud data lake using things like Amazon S3 or Azure's ADLS. They could be data stored in databases. They could be data stored on-prem and things like Minio, okay, Dell ECS, et cetera, et cetera. Doesn't matter where your data is, they can all be organized, documented, and governed through Dremio's semantic layer. Okay, so that means if the marketing data product is using let's say Snowflake, and then the finance data product is using ADLS to store their data, it doesn't matter because basically Dremio acts as sort of like this merger of all data streams. Okay, so you can imagine uh, basically it's like a data body of water that joins multiple bodies of water. Okay, so with that, again, you can create the semantic layer, this nice visual that, and your end users don't have to be thinking about where the data is. They just need to think what data are they accessing because they're organized into spaces like sales, marketing, supply chain, product, HR, finance. Okay, and then on top of that, Dremio has the features to help accelerate that data regardless of where it lives using Dremio's data reflections. And Dremio basically has an open interface so that data from anywhere that's nice and organized, documented, and governed can then easily be brought into whatever tools you need them into, whether it's for BI tools, Jupyter notebooks, be doing like ad hoc analysis and machine learning. Wherever you need that data, you can bring that data in via like Dremio's REST API, via Dremio's JDBC ODBC interface, or via Dremio's Aeroflight interface, and several integrations and clients that exist throughout. So it's this really nice solution for executing that data mesh. Okay, again, why do we need the data mesh? Because we're having all those problems because of the scale of our data. The question is, how do you implement that data mesh? Dremio is going to be a key point in making that very viable and very possible. Okay, so you can just kind of see it in action. Again, there's four sort of principles that make a data mesh a data mesh. Okay, first is domain-oriented decentralization. So the idea is that you break the data into logical units based on sort of like business units. So basically you might have like, this might be marketing over here. Okay. This might be finance. This might be supply chain. And that makes sense because they're going to understand the data better than anybody else. They're going to understand where the data is coming from, how it's generated, what are the semantics of the data to better meet those SLAs. Okay, so instead of having one big centralized team of data engineers, you'll have specialized teams of data engineers for each business unit that can, again, meet those SLAs, use the tools that are best for their specific set of data. Okay, and then all that data can then meet each other and get basically coalesce at Dremio. Okay, so basically they connect the sources to Dremio. Dremio provides that semantic layer that provides that ability to govern, that ability to organize, that ability to document, and again, that acceleration with data reflections all at the Dremio level. And again, from the end user's point of view, they're just pulling in data products. Okay, so this could be the, again, marketing data product, the supply chain data product. They don't care where the data lives. All they care is that, hey, I see the tables that I need. I have the documentation on the tables that I need so I can understand what data they have, so they can discover, they can visually see all the data they have available to them. So we address that discoverability. Again, there's the no copy architecture that Dremio brings, because generally you can generate variations on the same data through logical views. Okay, that way you don't have to be making many copies of the data. So you're going to have that consistency from less copies. You're going to have, you'll be meeting your SLAs, which is going to allow you to keep your data stale and also leave room, because you're breaking this up, leave room for better checks on data quality. Okay, the data is discoverable thanks to Dremio's semantic layer, and again, easily deliverable to where it needs to be delivered via JDBC, ODBC, and Aeroflight, and Dremio's REST API. But again, domain oriented. Again, these domains, then what they do is they create their own data products. Okay, so first we have to do is like, hey, these are the domains. Each domain then creates their own data product. The idea is that they're creating something for others to consume, and they have to kind of treat it like any way any business would treat a product. They got to think, what do my end users need? What is relevant to them? What is, what is the value proposition? And how do I make a quality product? And then there's like the self-service infrastructure, the idea that basically the tools they need allow them to, if you're the producer, to produce the data you need. Like they're not waiting on some centralized IT team to be able to go generate the tables they do with the tools that they use they like the most, but at the same time also for that data consumer to generate the variations on that data they need. Again, those logical views. So Dremio makes it easy for your domains to use the tools they like and then connect their data. Okay, so they can just basically self-deliver. But at the same time, it's going to allow your end users to self-serve because they can discover all that data on the semantic layer and then generate the logical views they need to see the data as they need it. Okay, and again, then you have data reflections always accelerate anytime you need acceleration. And then you have computational governance. So this is where, again, Dremio handles the governance piece. So basically, instead of having a bunch of decentralized governance, because you're thinking, oh, well, you have 20 different, domains using 20 different tools, and then they got to set rules up in all these 20 different places. That's going to be really hard to manage. But Dremio makes it where you have one central place to handle that governance. And when we say computational governance, it just means that like the governance is basically done via compute power in the sense that basically it is Dremio servers that are determining X can't access this data or this column or this row, via through technology. Cool. Okay, but again, in the steps in implementing all of this, first thing you have to do, again, basically you're breaking down your business into several domains. You're trying to figure out, hey, where are the axes of sort of domain knowledge? Okay, where we can basically gather a brain thrust that can really think through this data. Okay, and oftentimes, again, these are going to be your different business units, your sales, your marketing, your supply chain, your product. So you think through what are these different domains that are going to be responsible for provisioning their own data product. Okay, so again, instead of having one team of like 100 data engineers, I might have 5 teams of 20 data engineers, but each team can now be focused on a particular solution and using the tools that are best for that, how that particular data is structured and where it comes from and how it's coalesced, etc. Okay, it just makes thinking through of all of this much easier. Those teams can then be located with the people who are the subject matter experts in those departments, okay, where they can work with the people who are, generating the data in practice. Okay, and again, the data, it becomes very discoverable. Every domain would get its own space on Dremio. So you can see here, the creation of a space is just literally a quick couple clicks. And again, you can see all the spaces kind of listed over here. You can see all the data sets in each space listed over here as you click on them. Again, you have this UI that makes the data very discoverable and again, very organizable because I can create those spaces on Dremio quite easily and then delegate control over those spaces to the people who need it within each of those domains. We can then connect their data sources and then again, curate that data. So it just makes it just easy. That's the point. Okay, Dremio is going to basically make anything with a data lake or a data lakehouse easy and fast. That's the bottom line. So if you need more ease of use, Dremio's got your back. If you need more speed, Dremio's got your back. But then you got to standardize semantics. Okay, so basically, yes, each team has their space, they're pulling in all their data, but oftentimes you're going to try to do some sort of semantic logic as far as how you organize your data, because oftentimes you will necessarily have multiple versions of your data signifying different parts in sort of the process of curating that data. So you might have your raw data. Okay, so sometimes it's referred to as like raw or bronze. Then you're going to curate that data, do your joins, whatnot. So that might be in the next layer, and then have and then basically have like your production level data, which could be like gold or application. But the idea is that you want everyone to kind of have shared meaning when they use terms like this, like bond, silver, gold, raw business application, whatever terminology you're using, you want to standardize some semantics. So that way, when I go to any data product, even though that separate team has prepared that data product, it's organized in a way that I can semantically understand. Oh, okay, the data I want to look at is here in this, and the goal is in the finance space under the gold folder. Okay, so you want to kind of standardize those semantics. There's different ways to do it. Its bottom line is just generally you're trying to create some chain that people can understand. The version of the data I may need for this purpose is probably going to be in this folder because the term, and it's the way I understand it, means this. So again, raw means the raw data, which for certain situations I might need the raw data. For certain situations I might want the curated data that's already joined, but you want to have those semantics clear so people can be much more easier discoverable discover that data along with the documentation you can provide on Dremio through the built-in wiki, which makes life a lot easier. And then you want to govern that data. So basically, again, every department is going to basically connect their data after they've created their data. So again, they can go connect their S3s, connect their snowflakes, connect their ADLSs, connect whatever. Okay, to their then basically distribute that data through views on their space, and then be able to govern the access to that data via their space. So you can actually use role-based access controls where you say, hey, certain users and certain roles have access to certain spaces, folders, individual data sets. But you can also do row and column access rules. Okay, so through SQL UDFs or SQL UDFs, you're able to create policies that can mask data when basic users who shouldn't see the data are looking at that data form. Again, this avoids you having to make additional copies or additional views because the data is going to be masked for those who it needs to be masked. So instead of creating like a second view that doesn't have that column, you can now just say, hey, if the wrong person looks at this, they're only going to see what they should be able to see. Okay, and you can do that at the row and column level. Pretty straightforward. You can just basically set different masking policies and row access policies, and have it basically have that granular access. And again, it doesn't matter what the data source is. Okay, so wherever your data exists, Dremio's basically fine-grained access rules can be applied to it. So basically, again, it gives you that nice central layer to handle all the security issues when you're providing it to all your data users. And the end result is you end up with something like this, okay, where basically you have your data sources, okay, and it doesn't matter where the data is, it just filters into Dremio, into these different data domains, which again, it can be spaces over there on your Dremio dashboard. And each space could be one domain, and then basically within that domain, you have all the views that are the provisioned or the curated versions of the data that product wants to make available. Okay, and again, your end users who want to use that data for BI, data science, apps, okay, can then basically access all that data through Dremio's unified access layer. Okay, because again, that JDBC, that ODBC, that Aeroflight, that REST, or the actual web UI, they're able to see, discover, read the documentation of all that data. And again, they're not thinking about, hey, where does that data live? They're just thinking about what data do I need? They're thinking about their data semantically and logically instead of thinking about it technically. Which is going to allow them to focus more on sort of extracting the insights and using that data in insightful ways and being able to they're going to get that. So basically, by summarizing, by implementing data mesh, you have the divided up teams that are going to allow you to meet those SLAs quicker and make sure that data is consistent, fresh, okay, and correct. But then Dremio's access layer makes sure that that data is governed and discoverable. Okay, and basically at this point you're kind of hitting that data utopia. Okay, I mean there's always room for further optimizations as we journey to the world of perfect, but the idea here is you're addressing many of those concerns that we talked about at the very beginning in a very easy to use platform that is also fast. Again, that's the benefit with Dremio. You can do things with your data lake and data lakehouse that before were only dreams, and you can do them easily and you can do them fast. So that helps you. Hopefully this paints the picture of sort of like how you can use Dremio to execute a data mesh on your data lake or data lakehouse, and basically what the Dremio semantic layer can really provide. Again, providing that really easy access point that is discoverable. So I can discover data, or I can see documentation of my data, and basically I can only access the data that I've been given access to because it's governed, regardless of where that data is, regardless of which data product it is. So basically your domain teams just focus on bringing the data, and then from Dremio you can focus on governing and making that data discoverable and understandable. So my name is Alex Merced, okay, from Dremio Developer Advocate. So now we're going to be heading over into questions and Q&A. So we'll switch over to that, and I look forward to answering your questions.
See me? Good. Okay. And now we're going to continue on with Q&A. So I see we got a couple questions already in there. So first off, the question is, are these layers virtual? So here we're talking about like the semantic layer and the different layers of views. So yes, it is essentially a bunch of virtual views so essentially you are, I don't know if I want to say the word virtualizing data, it depends on what you're doing, but the idea is that you would connect your sources. Those would be your physical data sets, so the actual raw data, but it would live where it lives. So in the case that you connect a Postgres source, the data would live in Postgres. You connect S3, the data lives in S3. You connect whatever, the data lives there. And then what you would do is you would create all these sort of views, which again are virtual. So you're not creating a copy of the data. And then you'd be able to kind of basically say, okay, hey, we want this data set in these spaces. And then again, the people who you delegate access to. So if I delegate people to the marketing space access over that space, they can connect their own sources and create views from the sources they connect. And then they can share those sources. They can share access to those sources to those who they want to give access to. So that way everyone gets access to the data that they should have access to. Okay, but yeah, the idea is no copies. Okay, so that way you're not duplicating your data. And then when you use tools like DremioArctic, which we've talked about on other weeks, and you use like things like branching and merging to isolate ingestion, that's also a no copy approach. So everything we kind of strive for at Dremio is to try to minimize the amount of physical copies, yet still give you that crisp performance. Okay. Now, this kind of leads into the second question. How do you handle data that is common among all business domains? You place it in a separate domain. What you could do is you could connect it at basically that source could be connected from the administrator level. And then again, you can create that raw view in each domain. So that way each domain has that raw view to work from and build their data sets from. But again, you're not making a copy. So each of them would have sort of like their own unique view on it. And then they can then curate their different data sets from there specific to their domain. But again, you're not duplicating the data. So because of Dremio's unique sort of no copy architecture and the way it kind of handles a lot of that semantically, you are able to easily distribute that data set multiple times without having to make multiple copies. So in that case, if that data set changes at any time, all the data sets derived from it, all the views derived from it will all automatically sort of be in sync and be updated. So you don't have to worry about that sort of inconsistency when you're trying to reuse the same data across multiple domains. So that would be there. Let me just mark these questions as we go. Again, you can put your questions in the Q&A bucket. Okay. Answer that. How does Dremio create aggregates of data across different logical business domains? Okay, so essentially what's going to happen is that like when you're running, like let's say you run aggregations, whoever's running the query is going to have access to whatever data they have access to. So if I have access to multiple spaces, multiple domains, I can work with that data however I want. So I could run a query across and do a join from this data set, this view from this space to that view in that space. It's just a matter of what data you have access to. But now if you're trying to if you're talking about things like data reflections, which is a feature that allows you to accelerate. And again, just a little bit about data reflections. The way I would kind of think about it is like they're really intelligent, smart materializations. That are generally, they're kept in sync. They don't require you to query a separate namespace. They just kind of happen magically under the hood, and they'll reuse the same materialization for multiple views when possible. So that way you minimize the amount of materializations needed. But also with data reflections, you're able to create what's called an aggregate reflection, which will then create a materialization of the aggregate results of the table. But the bottom line is that it's generally you switch it on based on a view. So basically, you would have a particular view in one of your domains that you want to accelerate the aggregations on, typically for like BI purposes. So that we have like, basically sub-second BI updates every time you're using it in Tableau or Power BI, and you would just flip it on there. But again, if I'm like at the consumer level and I'm going to create a BI dashboard based on data from multiple domains, I would probably then create a join at my end. So basically from my user level, I can create a join which would just be another view, so no copies. And I'm joining that data across multiple domains because I have access to multiple domains. And basically if either of those data sets, so if I join two tables and one table has a reflection turned on it, it will take advantage of that data reflection to accelerate the queries on that join. And then, or I could also make if I don't have access to create reflections myself, because there's different levels of access in Dremio, I could then always request that whoever manages that domain turns on a reflection on that, or request the ability to turn on data reflections on my join, and it just accelerate my join. But you have that flexibility. But at the end of the day, like just when the data is inside of a specific space, specific domain, it's not locked in there. It's just merely for organizational purposes. If I'm an end user and I have access to multiple domains, I can work with that data however I like. Okay, here we go. We answered that one. No copy. Okay, that was the response to the previous question. Is there distributed computing also? Okay, so basically when it comes to the semantic layer is just the organizational unit, but Dremio, the query engine, is doing it through a distributed computing means. It is an MPP system. Okay, so basically any queries that you run are being distributed across the nodes in your cluster for execution. But the beauty of it is that that's only if you use the Dremio query engine, you can still pull that data elsewhere. So imagine a scenario where you may have lots of data sources. You have some iceberg and delta lake tables on S3. You have some tables in Snowflake and whatnot. All of this gets connected through your semantic layer, organized into your domains, and then your analyst can then pull that data. That initial high-level query will happen at Dremio and use that sort of distributed computing. But they'll maybe only need, let's say they pull down let's say 100 gigs worth of data, then they can then bring that into that comes down via Arrow if you use the Arrow flight connection, and then you can easily put that into like a DuckDB relation and then query that further with DuckDB. So there's different ways you can sort of manage that if you do part of the query through the bigger higher level part of the query, using distributed computing with Dremio, and then bring that into a situation where you might want to use your local computing power with like a DuckDB and do further sort of ad hoc analytics like that. And we actually will be doing a podcast, a Gnarly Datawaves episode at the end of June on that topic. Okay, cool. Okay, how do you handle all large query results? 10 terabytes. It's gonna it depends on what way you use, but it's gonna send you the data, so it is gonna be a memory issue if you ask for a lot of data. I think there is a way where basically it's gonna break up the data, especially if you're using like Aerofly, it's gonna bring up the data, and you will basically you can request chunks of the data at a time. But the specific mechanism, if I'm pulling that data via the API, it depends what data you're pulling and for what purposes. That I'll have to kind of get a little bit deeper into the engineering weeds of Dremio and get a little bit more specifics on sort of what is the mechanism there. Okay. Does Dremio work with third-party IAM systems for management and user profiles? It does. Now the specifics of it does have integrations with lake formation. It has integrations with Privacera and a Ranger and a few other tools for security purposes. So there are a variety of integrations you can use for your security purposes. So those are options, and that's at the Dremio query engine level, and that would overlay your semantic layer and control security there. Okay, so let's answer that one. Let's answer live. Okay, or burst output that spikes really high. Yeah, that I would need maybe a little bit more context on this burst part, just paint me a picture of a scenario. But I have a feeling that's going to be a question that I probably will just have to kind of go back to engineering a little bit just to get the little more specifics on each of the exact mechanism of how it's handled. Are things being spilled to disk, stuff like that, and when. And so I would follow up with engineering and kind of get those details and put that basically once we post this recording, there will be a document with it with any kind of further details that along with the answers I gave during this. Okay, cool. Let's see here. Does Dremio provide APIs to write custom connectors to interface with enterprise sources at the software level? So if you're using Dremio software, the Dremio sort of self-deployed version, yes, you can create custom connectors. And basically you can see the core Dremio code is open source. So you can see that if you look up Dremio Community Edition to see kind of how those kind of connectors will be written. But also you have open APIs for not only can you create custom connectors, but you can also send that data anywhere because you have an API, you have a REST API interface, Apache Arrow Flight, Apache Arrow Flight interface, and a JDBC ODBC interface you can use to connect to the data. So any of those approaches can be used to connect to the data, and so forth. So just one moment. Okay, now basically, so basically any of those interfaces can be used to pull that data into any source, whether you're pulling it into a notebook, pulling it into a BI dashboard, pulling it into any way you can pull the data there, and you always have access to the UI to curate your data sets. So you can curate all your views, curate all your data governance rules straight from the UI, but anything you can do in the UI, you can also do via SQL statements sent via any of those interfaces I mentioned before. Okay, and that's with the Dremio query engine. Okay, provide APIs to write custom connectors. Okay, we just discussed that, so answer live. Can you enable caching in the Dremio semantic layer? It does have an element of caching already built in. So there's this technology called, and then there's other caching settings that you can change depending on the source. So it depends on the source that you're connecting, the different caching options. But let's say you're connecting object storage. There's a special technology called the columnar cloud cache. So essentially what it's doing is that the nodes in your cluster are going to be using NVMe storage, so solid, very fast solid state memory. And essentially what's doing, it's caching a lot of particular metadata about the objects you're accessing in object storage in there, so that we can access them faster. And it really eliminates like a lot of the latency when it comes to accessing data on object storage that might occur when you're making several API calls back to back for accessing lots of resources. So there, and then there's also caching that goes on as far as like caching actual data on those nodes to speed it up, whether you're talking about accessing data on S3 or you're accessing data on a Hadoop cluster. So if you're connecting like a Hadoop cluster, it's going to cache it's also going to cache the data on those executor nodes directly from the Hadoop cluster. So there are caching mechanisms, and you can tweak how those caching mechanisms work in those source connectors. So you connect the data. Every source has like settings you can tweak, custom settings you can change to tweak those kind of things and optimize them. Okay. Can you enable caching? Okay, we just talked about that. Thanks for a nice talk. Are you using some data-centric approaches at the Dremio for data quality enhancement? Now for like data quality enhancement, the story I would say there is really going to come more towards like the dataascode, data, Project Nessie level, where basically you have a couple different stories. You can do branching for branching data. So that way you can isolate ingestion on a branch and then do your data quality checks while the data is on the branch, not visible to your end users, and then merge all those transactions as one big atomic transaction once you've passed those data quality checks by merging that branch in. We did do an episode a little bit about that. We've done a couple episodes about dataascode. So any episode we have that has like a title dataascode gets really deep into that, and we have a couple more coming up next month. So, and then there's also a demo. If you go on YouTube and look up dataascode or DremioArctic demo, there's a video where I kind of demonstrate exactly how you can do that, how you can create the branch, manipulate the data on the branch. And the cool thing about it is that Nessie as a catalog isn't just a Dremio thing. Like you can connect to it with Dremio, but you can also connect to it with Spark, with Flink. So the idea is that you can move the data to a branch, operate that data, not just from multiple transactions across multiple tables, but from multiple tools, and then merge all of that work at one time, which is, I can't think of any other context in which you can do that. Thanks. Okay, that's what I just talked about. Okay, what happens when a query fails? If a node of a query fails? Okay, I mean, if a node of a query fails, like most MPP systems, there's redundancies. So there's going to be nodes that are set up for redundancies to keep that sort of that uptime, just kind of like with Hadoop and any other MPP system. But when a query fails, it'll fail and give you you'll have error logs that you can look at. You'll have error output. The Dremio interface has a really nice job profiler where you can kind of see exactly on the Dremio UI, you can bring up the job. You'll see all the details about the job. So if it's successful, you can see, hey, where did it spend time, so that we can optimize it. But if it fails, you can go deeper into the profile and see all the different executors and phases of the query. So you can see exactly where the problem was. So you can see the exact operations that were running where it stopped in a much more visual way. And if you have a Dremio support, then that profile is something you can actually download as a zip file and then hand over to someone at support, and then they can really break down and help you kind of resolve those issues pretty quickly. Does Dremio come with a good enough ETL capability, or need a third-party ETL to create complex ETL paths? Dremio's ETL, I mean, I would say Dremio right now is more key analytics tool, data distribution tool. So again, you have that semantic layer for distributing your data to your end users. But as far as like landing your data in the data lake in the first place, so getting that data into S3, you can do that with Dremio. And I think on like smaller scale use cases, like, hey, you have a, maybe a handful of, a few gig CSV file, and you want to CTAS that into an iceberg table, like you can do that. And Dremio handles DML on iceberg tables. It's DML, it's ETL-like capabilities are going to expand. But I would say in this current state, like Dremio would be more like sort of your, basically first you get your data into the lakehouse and then you analyze your data with Dremio. So Dremio would be your tool for organizing that data once it's in your lake, and then distributing and governing that data to the people. So essentially right now the story would be, you'd still kind of want one tool or one story for your bringing the data into the lake, and then Dremio will organize, document, distribute that data to everyone who needs to use it, and then help query that data. So the ETL story is evolving, but I would say in its current state, you'd probably still want to use something like a Airbyte or a Fivetran to bring the data into like S3 into iceberg tables, and then Dremio can then take it from there. Cool. Is there any more questions? Those were a good set of questions with lots of fun answers. I'll give another minute for anyone to ask me remaining questions. Here we go. I am new to this field. How can I start by downloading Dremio? Any link, please? Yes. What I would recommend, you just head over to dremio.com. So if you go to dremio.com, there's a getting started button. You also, if you really just want to kind of get a quick feel for Dremio, there's a button that says like test drive. Click on that, and it'll give you an opportunity to just kind of go into this test environment to try it out real quick. When I generally want to just play with Dremio and just play with it, there's a Docker image for the community edition that you can just spin up real quick. I have a video somewhere on YouTube if you look like spinning up the Docker container, and it's really quick. There's literally one command, it's running, and then you can just go into your browser and you can start running queries. Now keep in mind, if you run the Docker container, you're running it on your local machine. So, basically you're running a single node instance. So the speed at which it's going to process queries with just your laptop isn't going to be the same as if you had like a fully deployed cluster, using several nodes. But it'll give you an idea for the feel for the features, the ability to kind of play with the semantic layer, the ability to play with the settings and connect sources. It's actually kind of fun. I like using it for like little ad hoc query work just locally. Okay, but yeah, I would say dremio.com is going to be the best place to get that. If you go to the Docker hub and look up Dremio, you can find that Docker image. And then I will make sure I include some links to some of that in the follow-up resources for this seminar. Okay, again, thank you, Adam, for the kind words. Okay, is it realistic to replace the need for OLAP cubes of an enterprise data warehouse with all the layers of virtualized views? I would say yes. Again, it depends on the use case, but I think for BI, yes. Because what Dremio has is the data reflections feature. So basically, data reflections replace the need for cubes. Okay, essentially basically, instead of having cubes that require like a lot more management, and again, you're still kind of creating this copy that you kind of have to maintain, you have to sync, you have to kind of govern. The data reflections offers that sort of materialization to speed things up without the need of all that extra work. It's just going to make sure things are in sync. It's going to have those materializations to speed up the process. And again, you're not having to make that initial copy of moving the data to the data warehouse in the first place. So not only are you limiting the cube, but you're limiting the copy in the warehouse, in the mart, and all that. So particularly for BI, I would say it's very practical. The way that, I mean, basically, like I would say, like BI is one of Dremio's sweetest spots. Like the Dremio BI experience is chef's kisses. Yeah. Again, I mean, I would say the things that are going to evolve are going to be more like the ETL side story, but the analytics side of the story is pretty strong. Cool. Any other questions? Okay. Now let's take again, in the next couple of weeks, we have some other great topics. Again, I think we may have like another data mesh one, and then we also are going to have basically using Dremio to help wrangle data over there at Memorial Sloan Kettering. That's going to be a really great episode. You're going to see really like, a company where Dremio really had a large impact, and that large impact helps them be able to use that cancer research, much better and save lives. It's a story of really seeing like the power of this technology and the power of the data lakehouse and the power of the semantic layer as well, because like the semantic layer plays a big role in like how that data gets documented and making it more useful within that organization. Make sure to come back for that episode and hear that story. It's a really compelling story about really like how this technology and better access to the data is really saving lives. But with that, I guess that is it for today. Again, I'll see you guys next week. Again, this episode will be posted on Spotify, on YouTube within the next 48 hours. You can find, an audio version pretty much on any other podcast host or directory. But I will see you guys again next week at the same bad time, in the same bad place. Have a great day and enjoy.